Okay, so in this lesson, we're going to look at combining all of our transformations. So far we looked at dilations, translations, reflections, and then rotations. So now we're going to look at putting them all together. We're going to focus on drawing shapes that are rotated, reflected, and translated. So we're probably going to leave the dilations out of this. They're kind of a separate category of their own. And we're going to identify a rotation and drawing the image of a shape that is rotated as well. We're also going to create and analyze designs made with rotations. But we're going to focus mainly on the middle part there, where we're looking at our rotations, reflections, and translations all together. The outcomes we're going to cover are: first, create and analyze and describe designs using translations, rotations, and reflections in all four quadrants of a coordinate grid. Identify and describe the applications of transformations in construction, industrial, commercial, domestic, and artistic contexts. Solve a contextual problem that involves transformations. Draw the image of a two-dimensional shape that results from a given single transformation. Identify a single transformation that was performed given the original two-dimensional shape or three-dimensional object and its image. Draw the image of a two-dimensional shape that results from a given combination of successive transformations. And explain the relationship between reflections and lines or planes of symmetry. Now, a lot of these we've covered in the past, and we're just going to, they may show up again, they may pop up. So we're going to look at this example. Again, we're combining multiple types of transformations. Sherry is a coach for a synchronized swimming team. She is teaching her team to hold and rotate the pattern shown. It's important for the swimmers to keep the pattern symmetrical as they rotate. If the pattern is symmetrical, it will look like a reflection. And it's pretty close to it now, isn't it? It's a little bit off, but it's pretty close to a perfect example of this. Swimmer A rotates clockwise to the position of swimmer B. So remember, if we're rotating clockwise, that means swimmer A is rotating in this direction. That would be clockwise. So we're going to describe the rotation, stating the center of rotation and the angle of rotation. And then we're also going to want to show the lines of reflection in this pattern that the swimmers are making. Okay, so the center of rotation is going to be the center of all their heads. That makes sense, right? They're rotating from a central point. The central point is going to basically be located right here between all their heads. Also, the rotation is clockwise. I've already pointed that out because it says so in the diagram. So a rotation for this particular transformation is going to be a clockwise rotation. Here I've laid a 360-degree protractor over top. It's hard to make out the numbers, but what you may notice is that I do have the angle measure right here. Swimmer B's body is twisted a little bit, so it doesn't look to be perfect, but it's pretty close. Placing that 360-degree protractor on our image, we can see that the clockwise rotation is about 240 degrees. It may be hard to pick that out, but that's what it does say right here, 240 degrees. So if swimmer A wants to swim into position of swimmer B, she's going to rotate in a clockwise fashion 240 degrees to get to the same position as swimmer B. Okay, also what you might notice is that there are 6 lines of reflection. You may be unsure where those 6 lines of reflection are. So I'll erase that, and then we're going to look. First off, there will be a line of reflection through A. Oh, I better make sure I got my pencil turned on. there's a line of reflection through swimmer A up to the swimmer above her. She doesn't have a label on that one. Between the two red swimmers, though, there's a line of reflection from blue swimmer to blue swimmer. And there's a line of reflection from green swimmer to green swimmer. Oh, a little off. Hard to draw on this machine. So there's 3 lines of reflection. But what we also see, and I've got this drawn nicer a little later on, that in between each set of swimmers, there's also a line of reflection. So that there are 3 swimmers above my line of reflection and 3 swimmers below. So between each set of swimmers is also going to be a line of reflection. So here we go. We see it a little more clearly here. So there's 1 line through each color of swimsuit and 1 line between each pair of swimmers. So in total there are 6, and we'll count them out here. There's this one right here, 1. Then there's this one here, 2. This one here, 3. The horizontal one, 4. We have our 5th one here, and our 6th one here. So you can see clearly we counted out 6 different lines of reflection. Okay, so we've seen our rotation. We've seen how we can draw reflections in those. Now we're going to look for the next move. Sherry needs to show the swimmers how to make the pattern look like a star that is bursting as the swimmers move apart. She sketches the swimmers on a grid, which we see in position 1. First, she draws their original position, position 1. Then she draws their position after they move apart. We want to describe the translation of swimmer A. So swimmer A, right here, her head is approximately right here on what we'd see in the new in position 2, compared to position 2. So how does she get from this point right here to this point right here? Okay, so once again, we're looking to get from position A right here to position A prime right here. So what I'm going to do is superimpose the first diagram on top of the second diagram. And we see this right here. So now we can see where swimmer A was initially and where swimmer A ends up. And you may notice that it appears that she's moved 2 units to the left to the right, and 2 units, 1, 2, up. So she swam 2 units to the right and 2 units up. She didn't actually swim 2 units right and 2 units up, but that's how we'd actually do the translation. It's likely she swam straight backwards. Oh, gone too far. So the red swimmer A moves 2 units right and 2 units up. And that's how she got from her initial position to her new position in this starburst. Okay, so this example, we're going to look at describing how a pattern is used, creating rotations, translations, and or reflections. If I want to get from here to here, it's possible that I may have just translated over in this direction. But there's another way I can look at this. I can rotate my original object. I'm going to erase this for you. Okay, I can rotate my original object 90 degrees clockwise. So that would be, say in this direction, 90 degrees, and I'll end up with this object right here, or this image right here. Okay, now this is, right now, looks to me like an exact mirror image of what we started with. So how am I going to fix that problem? The next thing I'm going to do is reflect through the middle line. This is the line I'm referring to. And if I reflect through the middle line, then I'm going to end up with this right here, which is exactly the same as what I started with. So 90-degree clockwise rotation followed by a reflection through the middle line will give me the original object back. Now I can now translate up, or I can translate right, or left, or down. So it'll be 4 units to the right or left or up or down, however you want to look at it. Okay, so to summarize this, we can combine any number of transformations to create a new image. So we can combine a translation with a reflection and a rotation, or a rotation with a reflection then a translation. And it's possible that there are more than one transformation that will give the same image. We saw here that we could rotate and reflect, and we're going to get the same image. We're going to get the same image as if we translated 4 units in one direction. Now I can also draw a reflection line well, in any number of places, I guess, and get the same type of shape. So it's possible that there is more than one transformation that will give the same image in the end. So when you are attempting problems, you may have a different answer than someone else that you may be comparing with, but it doesn't necessarily mean you're wrong. It just means that you've gone about it in a different way. And that's really true of just about any math that you can do.